In this video, we want to talk about solving trig equations. So we want to review a little bit about how we have to solve trig equations. We're going to start with one that's pretty basic. Cosine x equals -1/2. Now, it's very important that you don't just rely on, oh, I'm going to go to my calculator and do shift cosine -1/2, and that'll give me the answer. That'll give you a answer, or an answer, a single answer. But just like saying in English, a answer is incorrect, you're still missing stuff, so it'd be incorrect. So it's very important when we solve trig equations that we remember the idea of reference angles. And so the first thing we do here is we need to find, or we're asked to find all solutions, getting ahead of myself, in two regions. And you'll see this in the homework as well. Sometimes they want 0 to 2 pi. Sometimes they'll want every possible answer. Well, to get every possible answer, we have to first find them from 0 to 2 pi. Now, before we solve the equation, we have to find the reference angle, x sub r, first. What is the reference angle? Remember, that's the angle in the first quadrant. Reference angles are always in the first quadrant. So if trig x is equal to a, whatever trig function you're dealing with here, it's cosine, then the equation for the reference angle would be trig xr equals the absolute value. And again, that'll be the angle in the first quadrant, where it's positive, in the first quadrant. Okay, so we begin our problem by solving for the reference angle. What angle in the first quadrant would have a cosine, would give you 1/2 as an answer when you take cosine? Well, this is one of these exact values that you really do need to remember. They come up enough that it's worth remembering them. And so remember that that is the angle pi over 3 for cosine. If you go back to the notes, if you go back to our notes, I gave you some illustrations of those exact values you should remember. So x sub r is equal to pi over 3. Now what we need to do is we need to also remember when sine and cosine, or when cosine is negative. And remember that little, you might remember that little graphic, all students take calculus. So all of them are positive in the first, just the sine in the second, tangent in the third, and cosine in the fourth. So cosine is negative in the second and third quadrants. And so at this point now we draw the picture, putting that reference angle into the first and third quadrants. And then we want to figure out what are those angles if pi over 3 is the reference angle. Well, reference angle is always that acute angle with respect to the x-axis. So the angle in the second quadrant, that's pi over 3 units short of pi. So our actual angle would be pi minus pi over 3, or 2 pi over 3. The second angle is in the third quadrant. In the third quadrant, it's past pi. So it would be pi plus pi over 3, or 4 pi over 3. So those are our solutions between 0 and 2 pi. And again, the way we do this problem is we find first the reference angle. That's the angle in the first quadrant that's equal to that value. In this case, it's pi over 3. We then place the reference angle into the quadrants that match the sign of our original problem, which, as we can see here, was negative. And cosine's negative in the second and third quadrants. And so then, once we do that, we work out what our angle is. Now, to find all the solutions, we first find all the solutions between 0 and 2 pi. We first find all the solutions between 0 to 2 pi. And then we write them out, saying, well, remember that cosine is cyclical. It repeats every 2 pi units. So what we can do is we can write 2 pi over 3 plus any multiple of 2 pi. So 2 pi k. Any multiple of 2 pi, where k is some integer. That just means how many times you're going to turn around the circle to get the angle. And likewise, we do the same thing, 4 pi over 3 plus 2 pi k. Anything in that format will be a solution to this equation. Okay. Okay, so we're going to look at some more examples in our upcoming videos, but hopefully this refreshes your memory a little bit on how to solve trig equations.